Hi everybody, today we are going to discuss about the basic concepts of finite automata and formal language. First of all, let us see what is an abstract machine. An abstract machine is also called as an abstract computer, is a conceptual or theoretical model of a computer hardware or software system which really does not exist. The various types of the abstract machine are finite automata, linear bounded automata, push-down automata, and Turing machine. In this particular module, let us discuss what actually is finite automata, the working model, and the types of the finite automata. So, a finite automata is a computing device that accepts or recognizes the regular languages. Finite automata is a device which recognizes the regular languages. The finite automata acts as a mathematical model and are used to study the abstract machines. The basic working model of the finite automata includes input file, control unit, and the last one is output. The block diagram of finite automata is as follows: input tape, control unit, which consists of the various states like Q0, Q1, Q2, Q3, Q4, Q5 and so on, where it always points to the first element of an input tape, and the next one is output, which is either accept or reject. So what actually all these three components mean? An input tape is divided into cells, each of which can hold one symbol. This unit may be a control unit which consists of various states denoted by Q0, Q1, Q2, Q3, Q4, Q5 and so on. The starting state, that is Q0, is considered to be as the start state. Output may be either an accept or a reject. Next, the symbols which we used in finite automata. This is a first symbol called Q0. A circle is used to represent a state. Here Q0 is the state of a machine. It is just a state of a machine. The second one is Q0 to Q1. A circle with an arrow which is not originating from any node represents the starting state of the machine. Here Q0 is called as the start state of the machine. Q0 with a two circle around them is considered to be as the final state. We represent the final state this way: Q0 to Q1. This states an arrow with the label 1 goes from the state Q0 to the state Q1. This indicates that there is a transition from the state Q0 on to the state Q1 on applying the input symbol 1. Q0, an arrow with the label 0 starts and ends in Q0. It starts and it ends in Q0. Q0 to Q1 with an input symbol 0, 1, which represent an arrow with the label 0, 1 goes from the state Q0 to Q1. This indicates that the machine in the state Q0 on reading 0 or 1 enters into the state Q1. So the last concept that we are studying today is language. A language can be defined as the set of strings obtained from clean closure, that is summation star, where summation is the set of alphabets. So there are basically 4 types of languages. One is type 0 language, type 1 language, type 2 language, and the last is type 3 language. Type 0 language is called as the phase structured language. Type 1 language is called as the context sensitive language. Type 2 language is called as the context free language, and the last one is type 3 language is called as a regular language, where we focus much on these, that is a regular language. So the regular languages can be defined in 4 different methodologies or 4 different methods of regular languages. First is DFA, which stands for Deterministic Finite Automata. Second is NFA, which stands for Non-Deterministic Finite Automata. The third is Epsilon NFA, which stands for Epsilon NFA, that is non-deterministic finite automata with epsilon moves, and the last one is regular expression. In our further videos, let us see how to solve the problems related to all these 4 methodologies. Thank you.